Today I'm going to demonstrate the Paneldes Raceway software. Before I start, I will do a brief introduction to the Paneldes design suite and Paneldes. I will also give you a brief introduction to the Paneldes philosophy and workflow and summarise the software's features and benefits. The Paneldes design suite, EDS, has three modules. Firstly, Instrument Manager is an instrumentation SQL database for producing loops, datasheets, hookups, termination diagrams, schematics, and reports. Secondly, Paneldes is an electrical CAD package for producing schematics, elementaries, one-line diagrams, wiring diagrams, 2D panel layouts, and many reports. And Paneldes Raceway, which features in today's demo, is used for creating a 3D plant electrical and raceway model and doing automated cable routing, etc. Paneldes Design Suite software has been continuously developed for over 30 years and has thousands of licenses in over 50 countries. EDS software is compatible with AutoCAD, BricsCAD, G-StarCAD, Microsoft Excel, Access, and SQL Server. And these are a few of our notable users. When we use Paneldes Raceway, we are doing both design and engineering. We model raceway and equipment in 3D using automated design tools. We are also doing clash detection, selecting appropriate components in Raceway, filling the Raceway to suit the appropriate standards, generating construction reports, and of course, cable routing. A few words about our cable routing. It is fully automated, offering huge time savings compared to Excel. Cables are realistically modelled and highly accurate. Our length and filling calculations are accurate, our transit management and power segregation systems are efficient. You can even route manually if you wish. We provide a live query of all data, manage issuing to site, allow tray dividers and provide full comprehensive reporting, including pull cards and centre of gravity. Paneldes Raceway is flexible. It has catalogue-based component and raceway selection, detailed 3D realistic block libraries, and a parametric construction option. We allow for user-defined parts catalogues and symbols, 3D accessory parts, 2D reference drawings, and we don't exclude any CAD functions. We provide tools for project-wide block replacement, project-wide properties changes, and extensive CAD XREFs are recommended as part of our solution. Interoperability. Our philosophy is to use open data. We use Microsoft databases, Excel for spreadsheets, and DWG for CAD. We believe in visual engineering. We want you to see and check your raceways, components, and cables in 3D. You can check your cable's route in seconds before issuing it to site. With accurate 3D modelling, you can achieve significant material and cost savings. For example, if your cable lengths and drumming are accurate, you avoid wastage. Your bill of materials is accurate, ensuring minimal over-ordering. Tray cross-sections are accurate, allowing optimum filling and potentially smaller raceway. Paneldes Raceway creates many automated reports: cable length and route, raceway cross-section reports and drawings, drumming reports, bill of materials, centre of gravity calcs, and staged cable management between design office and site. The best interface for cable management is Cable Scheduler. Cable Scheduler provides many advantages over a CAD interface for routing. One of the primary gains comes from database organisational features for easy staging of your project into manageable batches of cables. Paneldes Raceway creates construction drawings, 2D sections from 3D drawings. I can summarise the Paneldes Raceway workflow as follows. 1. Create equipment and cables. Connect these with Paneldes. 2. Generate input cable schedules with eBase. 3. Place equipment in 3D model with Paneldes Raceway. 4. Add Raceway to the 3D model. 5. Auto route cables. 6. View and check cables. 7. Generate reports. Today I will show you how we import or create our component and cable data, create our 3D electrical model, then route the cables and produce many reports and deliverables. I will also briefly show you a few shining examples of Paneldes Raceway projects from around the globe. Prior to doing cable routing, you will need upstream a cable list which contains cable specifications and termination data, i.e. where the cable goes from and to. Ideally, your project has electrical diagrams containing this information, such as this Paneldes single-line diagram. An Paneldes single-line diagram contains the terminating enclosures and devices, such as this transformer. Paneldes components contain attribute data, are smart and can analyse the connections of cables connected to them. In my case, I have a transformer connected to a breaker by 4 cables. The cable markers are also smart and contain attributes which identify the catalogue specification for each cable. The cables are stackable. This is faster than drawing in a line for every cable. Paneldes will automatically scan this diagram, ID the components, ID the lines connecting the components, and then capture the cables on those lines. From this information, a fully routable cable schedule can be generated automatically. I will now zoom in on one of the motors in the single line diagram. Each motor has a heater and a local control station. The Motor Control Center, or MCC, is cabled to the heater and the motor. 2 cables run to each. The local control station is cabled back to the PLC cabinet, which in turn is also cabled to the MCC. Another method of creating a routable cable schedule is to create cables in one of our database modules, Instrument Manager or Cable Scheduler. Note, my project contains a cable scheduler database and my single line diagrams. This causes the cables we have just seen in the diagrams to automatically appear in Cable Scheduler. I also have cables in this database that are not from the single line diagrams. There are large instrument multi-core cables that feed from the PLC marshalling to the various junction boxes in the project. There are also small single pair cables that connect the site instruments to the various junction boxes in the project. My connection preview shows completed loops, cabling and termination. These were connected with the database earlier. I have so far only discussed the creation of cables within the Paneldes design suite. It is also possible to import any sensible cable list from a third-party source. Once imported to Cable Scheduler, we can route these third-party cables. The third-party cable list must be provided in Excel format, contain the cable name and specifications, plus where the cable goes from and to. Cable list data is automatically streamed into Paneldes routing, simply by virtue of being part of an EDS project. Note, imports are done from the database's file menu. Cabled components, for example motors, instruments and enclosures, must be placed onto our 3D model before we can automatically route cables to them. The primary reason we need the components modelled for routing is to provide the position of the component. I will show you multiple methods used to model these components. Firstly, I will decrease screen clutter by turning off XREFs that I don't need. The easiest and least automatic method to position components is to select the components from a menu. I can use the Place Panel dialog to choose an enclosure to insert. I can select it from a catalogue, set its tag name and drag it into a position. Hotkeys are provided to automatically rotate and align, as well as object snap and surface snap the component. I can use the Place Device dialog to choose a motor to insert. I will set its tag name to M800, press the Construct button and drag it into position. On the dialog, an upstream bill of materials is provided for easy selection. The components that are inserted can be a simple parametric shape, or you can prefabricate an attractive and realistic 3D block to represent the component. I will switch the display to realistic mode. Note, the model will become a little larger and slower if you use extreme realism to display your components to a manufacturing or machining level. We typically choose a medium to low level of realism in our 3D parts. This takes less time to create and achieves our goal of visible recognition. I will now flip back to a wireframe display mode and investigate another insertion method. Prior to this demo, I have recorded the tag names, catalogue numbers and coordinates for the heaters, motors and instruments of my model. This information has been placed in a database table. The table contains the columns which are compatible with our Insert Assembly or IA program. I will start the IA function. In the IA interface, I can see the file I have created. I can view or edit the file using the Edit button. As we can see, the file contains the tag names, catalogue numbers, and the XYZ coordinates. I have based the coordinates on 0, 0, 0, so I will now draw the group at 0, 0, 0. The heaters, motors and instruments of my model have been inserted. Hours of modelling work is done in seconds. The IA function also provides facilities in the table to orient and annotate the inserted components. I will now switch back to realistic mode and look at some of the IA inserted components. The smart routable motors are overlaid on the model. Note the routing of these is targeted at the motor connection box. The smart instruments are also overlaid on the model. There are multiple methods of placing Raceway, such as tray, conduit, trench and ductwork, into a Paneldes model. A heads up, it is always a good plan to subdivide your model into XREFs in order to make construction easier and your model less cluttered. This XREF contains the tray for power level 2, which, in my project, is for instrumentation cables. The simplest means of placing trays is to use the Construct Raceway function on the Paneldes menu. From here I can simply select a tray type and drag and drop it on the model. I must choose the Raceway type and segment type. I want a linear tray as opposed to a conduit corner. I need specifications for the tray, for example its part number and dimensions. I will press the Construct button to confirm my tray spec and then drag and drop. I can attach the tray to my existing trays using one of multiple Smart Snap alignment methods. I will now insert a corner fitting. You will note that the dialog defaults to the last corner I was using. For the corner, I will use a Raceway end snap, which places the corner apex at the end of the existing tray. I will now add another linear section and then add a riser. On this form, we provide a catalogue selection tab for choosing pre-specified manufacturer's parts. We also provide a selection list for previously used components and a search tool to find matching fittings for your previously used trays. After snapping, I will use the Paneldes hotkeys to align my riser upwards. The riser needs to be an internal riser. Paneldes provides hotkeys for rotating on 3 axes, for offsetting a connection point, and for changing the end of connection for the component. I will now take a quick look at the realistic view of my new smart tray using the Orbit command. New bespoke Raceway can be created efficiently and accurately with this Paneldes method at any time. It is also possible to simply copy sections of tray with AutoCAD commands. Paneldes and our global editor will assist to manage the tray names and specs. I will now find and insert an X-section fitting that I can use with the existing linear tray. Paneldes breaks the fitting into the linear tray and renames the residual short trays. Obviously, I can extend my Raceway network from this fitting with the same methods. The fittings available in Paneldes include corners at most standard angles, inside and outside risers, T's, Y's, X's, and both offset and centered reducers. I will now demonstrate a second method to create new Raceway. This is the polyline trace method. Polytrace brings extreme automation to the design of Raceway. You draw the Raceway paths and junctions with a 3D polyline, and we create a realistic 3D model of the Raceway from these polylines. You can use any of the out-of-the-box CAD functions to create the polylines. We provide a small tolerance for junctions on the polyline network. If Paneldes sees a junction within that tolerance, then it will use a fitting to join the trays. I have created a forked network with 6 dropper trays. To run the polyline trace function, I need to again open the Construct Raceway function on the Paneldes menu. I will choose the base linear tray. This will be used for all of the straight selections of my forked network. This time I will use the Trace a Polyline button instead of the Construct button. I must confirm the tilt angle for the first tray in case it's on its side, and I also must select the 3D polylines that I want to trace. Paneldes will automatically find fittings that have the same size profile as the base tray, then create my Raceway network. We can now zoom in and inspect some of the newly created trays. This process has taken approximately 2 minutes. It is highly efficient and will reduce modelling time by 90% for most users. Outside the project control room I have some transformers. For the transformer cables I wish to use a trench containing trays and conduit risers. For the conduit risers I have drawn 3D polyline centerlines. I will now use the polyline trace function to form the conduits. Now I will use a scalable insert assembly group to create a trench with 4 parallel trays and repeating mounting brackets. This time I will manually place the group on the model. I want to align it with the construction line I have created. I can object snap to the construction line and rotate it with the hotkeys. Then I can stretch it to the correct length. I will now take a quick look at the completed trench in realistic mode. To recap, the important feature in IA construction of Raceway is the linear scaling available. If you have a long run of Raceway with trench, multiple trays and conduits, repeating brackets, etc., then IA is an efficient method to create it. The last method of creating Raceway for today is the duct bank editor. I need an EDS trench to edit as a start point. Once I have selected a trench, I can design its conduit cross-section. I use the Add button to add a conduit and use the Raceway dialog to specify the conduit's tag name and specifications. I will drag each conduit to the desired location in the cross-section. I will quickly add another 8 conduits. Note, when adding conduits, I can use all of the features we observed earlier. For example, I can select a conduit specification from a manufacturer's catalogue or from my previously used component list. When my cross-section is complete, I will use the Construct button to create the 3D conduits. Immediately after construction, the editor is repositioned at the entry point of the next trench. This is at the far end of the newly constructed conduits. The current trench is identified on the top left corner of the editor. At any time, I can select a group of conduits in the trench and make adjustments to their construction parameters. I'm going to stub up the conduits and change their overall length to extend out of the end of the trench, closer to the transformers. The cross-section now indicates that the conduits will stub up at the end of this trench segment. I will extend the length of the lower conduits to avoid them clashing with the upper conduits. I will now exit the constructor and examine the duct bank. To recap, the duct bank editor provides a fast and efficient method of creating underground conduit arrays or road crossings. As mentioned during Raceway construction, it is very important to avoid CAD slowing down and to construct without screen clutter, making your snaps difficult. One of the best methods to achieve this is to subdivide your electrical model into many XREFs. Subdividing your electrical model by power levels, e.g. instrumentation or LV, is a good choice, and this can be combined easily with a geographic area subdivision. An example of geographic areas could be the floors of a high-rise building or similar. Another common subdivision is the component type. It is sensible to separate your instruments from your trays and your trays from your enclosures. Single component types also tend to be separated by workflow and personnel. In this model, I've subdivided my work by component type, power, and I have also separated out the control room and transformer areas. The larger your model is, the more valuable you will find subdividing it into XREFs. Most electrical objects of the same type in your model will look very similar. The only way to positively identify them is to view their tag name and specification. The components, once loaded, can be identified and interrogated using our query command. The upper list in the query tool contains the tags of items selected. If the item is highlighted blue in the list, then it will show a magenta crosshair on the model. The lower list in the query tool contains the tagging and specification data of the component which is currently blue. The tool has a find window which can search for a group of components by name or any specification. My search has selected all components with a tag name starting with M. This includes all of my motors. The motors in view and selected are M500 and M600. One of the most powerful tools in the Paneldes design suite is the Global Editor. The Global Editor allows you to, en masse, manage tag names, specifications and positions, project-wide. To select components for global editing, we use the Query tool, which I have just demoed. When the desired components are in the top list, we press OK to edit them. I have selected 3 linear trays and a riser to edit. I will reselect specifications of the 3 linear trays from the Cooper catalogue. I will select 24-inch tray to replace these 18-inch trays. Note each tray's catalogue record has many dimensions and filling properties. I will now repeat the process for the riser fitting. This is obviously a different part number to the linear tray and will have additional properties such as bend radius. Properties such as naming and power segregation are not part number specific and therefore are not catalogued. They are design and project dependent. I will change the power segregation level of the trays to power 0. Power 0 is a wildcard, meaning any cable can run through the tray. I will save the changes, update the model and then inspect it. The trays are all larger, the green colour indicates power 0 and the fittings are fitted in the run. Global Edit is extremely powerful. You could accurately change hundreds of components on many files in seconds. This would take days using pure CAD. As a final exercise, I will demonstrate another aspect of polyline trace, the ability to merge new trays in with existing runs. I will draw multiple 3D polylines across some existing trays and then merge my new trays with the existing. The Place Raceway dialog is used to select the new tray type and naming. I again will use the Polyline Trace button and then select the polylines of interest. The complex tray network is now formed from the old and new trays. To recap, existing EDS components on your model can be identified and changed manually and automatically with the efficiency and accuracy using EDS tools. I now have a model containing accurately positioned components such as devices, instruments, enclosures and Raceway, so I can start the cable routing. I will firstly remove the non-electrical XREFs from the model so I can see the resultant electrical model and cables. I will do my routing from Cable Scheduler. In Cable Scheduler I can route automatically or manually. Note manual is 10 times to 50 times slower, however redundant cables may require this. Semi-automatic routing with waypoint guidance is also possible with Paneldes. This is faster than manual routing. I have divided my cables into 6 batches in 6 folders, some with single line diagram cables, some with database cables. I will work in the JB Cables folder first. The JB Cable status column says unrouted, and also the cable icons are not marked as routed. The cables are all terminated to or from one of the model's junction boxes. I will now select all of the cables in this folder. There is a convenient button on the right button menu for selecting all items in a folder. Looking at the right button menu, there are functions to view routes, guide cables with waypoints, copy routes, and to manually route. I will start the automatic routing process. The process only takes a few seconds typically. Multiple progress bars are displayed as the cables are processed. When the routing is completed, a statistics report is displayed. This can tell you about success and performance of the preceding routing. The interface is loaded with your newly routed cables and their routes. The cable icons are now marked as routed. The status column of the cables now says routed, and the estimated length of each cable has now been loaded. As a point of interest, the JB cables are instrumentation cables with dedicated Power Level 2 trays. I will now work on my second batch of cables in the heater cables folder. Again, this new batch is marked as unrouted. I will select the heater cables and auto-route them. The cables are now marked as routed and their lengths are now displayed. The next batch of cables, the motor cables, contain a mix of LV and control cables. There are 32,000 levels of power segregation available in Paneldes Raceway to easily support your requirements of cable separation. I will select the motor cables and quickly auto-route them. The motor cables are now marked as routed and their lengths are now displayed. I will now inspect the tree view of one of the routed cables. Underneath the cable I can see a green Raceway group representing the cable's new route. The route contains many Raceway segments in route order. Note, a Raceway segment is either a tray or a conduit or a fitting or a trench. The route is used for making a pull card for construction. I will show you this a little later. Each Raceway segment understands its size, power, segregation and filling constraints. When I select any Raceway segment in the tree, I can view the cables that are currently routed through that tray. The routes, segments and cables may also display warnings if errors or bottlenecks occur. In the database, the tray carries information such as its part number, its power segregation level, its description and its fill information. The routes, the filling and the length results are now in the database. This automatic routing and filling process is far more efficient than traditional methods. What I have not done so far is view and check my routing. I will now use the right button menu to view the routes of the selected cables in CAD. There is always a chance that a modelling error could have caused an overlength or misdirected route. Typically, we view cables primarily to check them. If the route appears sensible, then it is most likely optimal. When a route does not look correct or has a warning, then your next step is to use the Paneldes diagnostics tools to examine Raceway on and around the route. When viewed, the cables are modelled far more accurately than when using traditional methods, such as using Excel-based calculations and centerline-based measures. This increased accuracy can save miles of cable and volumes of rework. The cables I have modelled are all of the cables running from the MCC out to the plant motors and heaters via the Power 1 low voltage tray. The cables all share the same frame in the transit, which is exiting the control and power building. The tray out to the plant looks tidy and the T-junction in the plant looks good. The cables all appear to be tracking nicely to their in-plant destinations. Note, trays can be physically split with dividers if they are filled with mixed power cables. Paneldes tracks and manages these splits to ensure the cable cross-sections are accurate. I should mention waypoints. Waypoints guide a cable around an area or obstacle by naming one or more trays that the cable must go through. Sometimes this is necessary, for example in a cable redundancy situation. Note, any manual intervention will be very slow compared to automated routing. After routing, we can produce cross-section reports and diagrams automatically to assist construction. This applies to trays, ducts, trenches and also to transits. I have prepared some automated cross-sections for some of my trays. Each cross-section contains cables linked by a code to the cable list alongside. When considering cross-sections, I should mention that the fill calculations are all done during routing, prior to drawing cross-sections. Filling can optionally use NEC filling rules. Transit cross-sections are also calculated and drawn automatically with Paneldes Raceway. If you are familiar with transits, you will realise that transit filling is a science of its own and can consume a considerable amount of an engineer's time. Paneldes Raceway automates the transit packing process, saving your company time and money. Cables are best staged in batches and best managed when organised in folders. It is highly inefficient to try to work in a spreadsheet with 10,000 rows of data. In a project from the early stages, you can often design Raceway and route cables before other parts of the plant are finalised. Examples are underground systems must be designed before the above-ground raceway, or in a high-rise, cables on the top floor are normally pulled last. I will now lock the motor cables batch as I have checked these. Note how the status becomes locked and the icon shows a lock. Paneldes Raceway provides a staging system to lock checked cables, issue them to site and to mark cables as pulled. This enables you to batch your cables. Batched cables allow you to schedule your work in sync with your construction teams. I will now spend a couple of minutes demonstrating some special routing situations. The first one I will demonstrate is a cabling space. A cabling space is an area where cables can run freely, such as the ceiling cavity in an office building. In Paneldes, we simply create an area and mark it as a pull zone, and then any raceway entering it can pass cables to all other raceway exiting it. My model has a couple of vertical conduits entering my red pull zone. I will view the cables and routes using these conduits. You can see that the route leaves the distribution panel and uses the tray until the cable arrives at the first vertical conduit. When the cable exits the vertical conduit, it forms a path approximately parallel to the faces of the pull zone. The cable then exits out of the pull zone through the second of the vertical conduits, then arrives at the load, lamps in this case. Note the route uses splines to transition around corners smoothly. Pull zones can often be devoid of raceway. You could use a pull zone in a ceiling, a manhole, in a ship's or offshore platform's cableways, or in any vehicle. Another special feature of Paneldes routing is the ability to define a no-go area for cables. In this case, an area or accessory can be marked as an obstruction. Cables in a Paneldes model can route anywhere where raceway is provided, but sometimes trays can get too close to the other trays, allowing undesirable routes to develop. GIS substations and offshore projects are notorious for this. We can stop these close raceways from sharing cables with an obstruction. In my model, I do not want any of the raceway used for the east transformer to be used to carry cables from the west transformer, and vice versa. I have placed a red obstruction wall along the centre of my trench to stop the sharing of the east-west raceway. Another feature of Paneldes Raceway is the smart transit system. Transits can be modelled and the routing system will route through them. Paneldes Raceway knows how to optimally fill the transits and how to select and quantify appropriate filling blocks. You can see a 3-frame Roxtec transit under my distribution panels. The transformer cables are routed through this transit. Transit frames are power level sensitive. You can mix or segregate your instrumentation cables from your LV cables by frame, etc. After routing your cables through the transits, Paneldes can automatically provide your construction team with transit cross-section diagrams and their cable lists. Our transit system provides a full materials list and a cross-section report as well as cross-section diagrams. The transit system is ideal for offshore room isolation and ship bulkhead designs, with each transit able to selectively allow power to enter a space, or not. Routing and tray design is an iterative process. You can't know how big a tray is until the count of cables in the tray is established. However, routing, not yet done, affects that cable count. In a new model, many trays are likely to be undersized, so cables are blocked from using them and may route incorrectly. We can use the Query Conductor tool to examine and check cable routes. The Query tool shows the cable's naming, specification and termination data. The Display Route button highlights all of the raceway segments in the cable's route. If the tray is highlighted blue, then it will have a magenta crosshair displayed in the model. My route visibly looks excellent. There is no short path, so I have no reason to check it further. However, if I did suspect it had taken a wrong turn, I could step through the trays along the route and examine the filling and any warnings on the trays. An engineer only needs routing diagnostics to understand why a route appears to be wrong. As I step through each tray, you can see the filling of that tray. The tray is also highlighted with a magenta crosshair on the model. When a cable appears to be going the wrong way or not finding a route, we provide a diagnostic system called the bottleneck system. The bottleneck system allows a cable to pass through bottleneck trays. Bottleneck trays are constricted, undersized, badly connected, or have an inappropriate voltage level. Whenever a bottleneck tray is used in a route, the query tool marks that tray. If the routing system produces a shorter or more desirable route using bottleneck trays, then those trays are probably undersized or badly positioned. You can simply increase the size or position of the bottleneck segments to ensure the cable takes the best route. Paneldes has a system for field routing of cables. When you do not want to model small conduits to devices, you can enable a jump to the device instead. The jump can connect over a distance which is significantly larger than the normal Paneldes connection tolerance. You can also add a preset extra length to the cable. This will accommodate the extra length the installers will need to field route the cable. Paneldes components can be modelled as 3D blocks, containing solids and, of course, attributes for tags and specifications. The system is efficient and provides a realistic model. The block I am displaying is a cable ladder. You will note that the ladder does not contain extreme detail. Extreme detail will slow down a CAD engine. You can easily make your own component blocks. NEC filling calculation is an integral part of Paneldes. The US National Electrical Code is a comprehensive and safe standard for electrical construction. NEC is also rather complex when compared to other standards. This is primarily because of its comprehensive nature. NEC filling is applicable to both metric and imperial projects. There are a vast number of settings and preferences in Paneldes. User preferences are important to us. Paneldes allows you to do the engineering your way. Take care. Some of the preferences you will encounter could adjust the tolerances of routing or change the way your model is constructed. EDS creates a set of report tables within the project database. These tables contain the raw data for all EDS reports. They are found in the reporting folder. We can examine the bill of materials report data table. In this table we can see the manufacturer and part number and the tag name and description for every component in our project. Another table is the BSUM materials summary table. This table contains the quantity of components for every part number and manufacturer. The cable drum data table assigns all cables efficiently to a series of named drums. This report includes the part number, cable specification data and the wastage on each drum. I will now examine the cable schedule report table. This contains the cables in the project and their spec data. The from and to termination data is also included in the cable schedule report. A transit materials report table is also supplied. We will now examine the formatted reports. All formatted reports use templates, which you can customize, adding your own columns and formats easily without programming. The formatted reports in this project are located in the SQL Server report services. The first report we will inspect is the cable core list. This is a construction report used for terminating your cables. This contains all cable cores, also known as cable conductors, and the terminals they are connected to. The report also contains cable spec data. The cable drum report uses the table we inspected earlier. It contains the drum name and part number. It also contains the list of cables to be cut from the drum and their lengths. The wastage from each drum is also included. The cable schedule typically contains much of the data required for EDS to complete its task of cable routing. The cable name, the from and to enclosures are included in this report, as well as the cable specification data. The length of each cable is also included after routing. The routing and filling for the cable are reported in the pull cards and tray report that I will show you later. I will now inspect a materials list. I have multiple materials lists with different sorts and groupings applied. This report is the quantity summary. The quantity summary is ideal for your purchasing department. It contains the manufacturer and part number, a description, and a quantity. The next report we will inspect is the pull card report. This report is a construction report informing the electricians of the route of each cable they are installing. Each card includes the cable name and the from and to device or enclosure. The cut length for the cable is included. The cable type and ratings are included. The route is listed, including each tray, conduit or trench in order. The final report is the Raceway cross-section and fill report. This report is a construction report informing the electrician of the cables in each tray. Each block includes the Raceway name for the tray, trench or conduit. The tray length is included. The percentage fill is included. The list of cables for a tray is included in the lower half of the report block. Just a quick reminder, EDS reports can have pretty much any content, any sorts or grouping, and any format and graphics. I will now show you a few examples of Raceway models completed recently. This model is an air-insulated DC link transmission station modelled for a North American power company. The majority of the cabling around the site is underground and routed in concrete encased trenches, coupled with conduits to feed the site components. This project was completed with imperial dimensions. The next project involves the power distribution and motor control centres for an Australian water purification plant. This system involved tray, conduit, duct banks and transit management and was a metric project. This model highlights the transition from underground to overhead using conduit and from within a building to the exposed site using transit penetrations. The final model I will show you is an offshore metric project from the Eurozone. The project involves a large wind farm and the Raceway modelling and cable routing for the entire offshore substation. All the rooms in the substation were sealed and over 300 transits were used for penetrating the walls, floors and ceilings for cabling. Being a GIS substation and being offshore, there was minimal space between cabling, trays and other components, and the 6,000 cables were continuously in danger of undesirable routing jumps. Paneldes Raceway completed this project and 3 others like it successfully and efficiently for Iberdrola. To conclude, here is a summary of benefits that you will get if you use Paneldes Raceway. Most of the modelling, cable routing and calculations are fully automated, giving you enhanced accuracy and efficiency. Modelling is realistic and visually accurate, leaving less room for errors and thus enhancing your accuracy. Efficiency tools are provided to manage transit filling and also power segregation, thus saving significant amounts of time. Database enhanced cable management, including a staging and issuing system, reduces project time and enhances your efficiency. Viewed in another way, we get accuracy from single database consistency and library use consistency. Checking and verification is easy with auto error checks. We get accuracy and efficiency from automated filling, automated lengths, automated routing, automated reports, catalogue usage and materials management. We gain efficiency from automated construction of the model, modular use of libraries, transit management, staged issuing, use of common formats. Gains in accuracy and efficiency results in less rework, faster completion, higher quality, lower cost. How good is Paneldes? A satisfied customer said, Downer Engineering's power business in New South Wales, Australia used EDS in the generation of all loop diagrams, termination diagrams, 3D cable tray design, auto cable routing and cable scheduling for the Pinjarra Unit 1 gas turbine power station. This resulted in significant improvements in terms of drawing accuracy and quality.